Okay, so we have established that sound is created by vibrations, by vibrating molecules. And in the last concept that we tried to focus on, I showed you a compression wave where it shows the molecules moving in a sort of pattern, and that is a compression wave. But then I showed you a transverse wave, and you learned the major parts of the transverse wave. And then I gave you time to play on the oscilloscope, which is attached to the Google Classroom. And so I want to walk through the next big concept we've got to master today, the last one, which is what is frequency and pitch. So energy is being passed through the molecules when sound is occurring. And when you played with the oscilloscope, I hope you were seeing transverse waves that looked a little like this. Did you notice those important parts, the top being the crest, the bottom being the trough? And did you notice patterns that you could create with varying wavelengths? There could be a wave with a lot of a oscilloscope with a lot of waves happening or not very many. And I need you to figure out today how to produce just a few or a lot. So first of all, let's establish that here is a low, deep noise. If you were in music class, or if you ever heard somebody say you have a deep voice, then a deep voice should sound like this. Okay. And then here is a high-pitched noise. Okay. Both of those I did not say very loud. When I am talking about my high or low noises, I am talking about how high or low they sound, not how loud or quiet they sound. So high, low. Okay. All right. So when we work with a low, deep noise and we look at it on the oscilloscope, then we're going to see something called a low frequency wave. If there is a low frequency wave, there is not a lot of energy. There's a low energy, low frequency. And when we look at a high frequency wave, then we are going to see a lot of waves. There is a high level of energy per second. And so let me just demonstrate real quick for you. Here I'm on the oscilloscope. Let me show you with a low wave, and I'm going to freeze it. And so if you do the same thing, you're going to see here's a trough, here's a trough, here's a crest, here's a crest, here's a crest. But there are not a lot of waves, and this is per second. But now let me repeat what I need to call this kind of wave. Since there is not a lot of energy, I call this a low energy. But when I lowered my voice, it is a low pitch, low frequency wave. And now let me show you a high pitch wave, what that looks like. Look at the difference. So when there is a high frequency wave, there are a lot of crests per second and a lot of troughs. And so the distance between each wavelength, the distance between each crest is much shorter than there is with a low pitch like this. So see how there's a greater distance when I use a low pitch noise. So I invite you to play with that oscilloscope and create low pitch and high pitch noises, low frequency, high frequency noises. But let's just clarify. Frequency is how often a wave happens per second. So this wave here, which sounds like, because it's high pitched, high frequency, it occurs a lot per second. This one, the lower one, is a low frequency, low pitch, so it sounds like, ugh. All right. How is frequency described or measured? It's described in something called hertz. So this one, in 1 second, there are 15 crests. So that would be 15 hertz per second, could be described as that. And then this one, in comparison, there's only 3. So 3 hertz per second. So frequency is how often a wave happens per second. and hertz is how it's measured. And now, how do different frequencies sound? Just like you've been hearing me try to do this with you. I sure miss doing this with kids so they can do it for me. But this one is a high frequency, high pitched, high energy wave. So it should sound like, and low frequency should be low pitch, and it should sound low energy like this. Okay. So, I would invite you guys to just, I wanted to say one last thing. Pitch is not volume. Please remember, pitch is not volume. Pitch is how high or low a sound or musical note is. Tomorrow, we can compare that to volume and how we can see that on the oscilloscope. But today, while you're thinking or talking to anyone, just experiment with how high or low pitched you talk. Remind yourself that the meaning of the word pitch doesn't have anything to do with volume. It's how high or low pitch something is, and it has nothing to do with volume.